For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. When everything is exotic and strange, the familiar beckons. And when it comes to exploring the solar system, the familiar calls us to Mars. Although it is clearly an alien world, Mars is also a planet with landforms we immediately recognize. It is a world with deserts and dunes, cliffs and canyons, a landscape we can imagine ourselves exploring firsthand, on 2 feet or on 6 wheels. But familiarity doesn't make Mars any easier to understand. After scrutinizing its landforms from orbit and sampling its soil and rocks from the surface, we have become better acquainted with Mars than any other planet in the solar system apart from our own. But our questions about its present state and complex history have only multiplied, including the biggest question of all: did life ever exist here? Mars is not like Earth, where life is abundant and obvious. It's also not like the Moon, where there's really no chance for life at all. Mars is somewhere in between, and so it can help us define where life can and cannot exist. When we journey to Mars, we journey to the borderland. Mars's borderland status is nothing new. Astronomers have been musing about the potential for life on the red planet for more than a century. When the first grainy close-ups of Mars were radioed back in 1965, scientists were surprised and a little disappointed. The images showed a barren and cratered surface, much more like the Moon than any place on Earth. Apparently, the red planet was the dead planet, and any notion of spotting life on the surface, even primitive life, all but vaporized. But first impressions can be deceiving. As follow-up missions arrived in the late 60s and 70s with increasingly better cameras, it became clear Mars is a far more interesting and diverse planet than anyone had realized. Yes, there were impact craters, but there were also signs of a colossal geologic history. Giant volcanoes, larger than any on Earth, were found towering over the Martian plains. The largest of all, Olympus Mons, rises to a height of 24 kilometers from its base, 3 times higher than Mount Everest, making this not just the tallest peak on Mars, but the tallest in the solar system. Such an impressive structure must have arisen through widespread eruptions of lava that poured out across the surface again and again, possibly over billions of years. Olympus Mons sits atop a giant bulge known as Tharsis that protrudes from Mars and makes it a distinctly lopsided planet. Ultimately, it led to a spectacular splitting of the planet's crust and the creation of this giant canyon, Valles Marineris. The proportions of Valles Marineris stagger the imagination. It is more than 10 times longer than Earth's Grand Canyon, and 4 times as deep. Today, the best images of Mars come from the Mars Reconnaissance Orbiter, an orbiting spacecraft that carries the most powerful telescope ever sent to another world. Capable of resolving details on the surface as small as a dinner plate, it has given us an unprecedented look at Mars in all its splendor. From exquisite sand dunes to tracks left behind by Martian dust devils. But perhaps the most interesting views are the ones that suggest water once flowed on Mars. Deep inside Valles Marineris, it appears as if there were layers of sediment deposited in shallow Martian lakes, long before the giant canyon formed. Even the shape and orientation of the terrain suggests water once flowed on Mars. These hints of a watery past grow much stronger as we cast our view beyond Valles Marineris to a series of large but empty channels leading away from the Tharsis Bulge toward the low-lying regions further north. Although they dried up long ago, these valleys must have been created by vast outflows of moving water that cut across the Martian landscape, spilling out into the northern plains. In some cases, these channels measure 100 kilometers across and carve their way through thousands of kilometers of terrain. Their discovery drastically changed scientists' view of Mars. Today, Mars is far too cold and its atmosphere far too thin for liquid water to persist on the surface. Yet these channels, which bear all the marks of catastrophic flooding, suggest that Mars once had water in abundance. If so, what caused the release of this water, and where did it go? The answer to the first question probably lies with the Tharsis Bulge. It now seems likely the intense heat that led to the formation of Mars's giant volcanoes also forced the release of vast quantities of water stored in the Martian crust. At first, the water flowed underground, but then it broke out onto the surface, creating the features visible today. Across Mars, there are other signs that water may have flowed billions of years ago. Strong evidence from orbiting spacecraft now suggests much of this water lies frozen underground in the form of permafrost near the Martian poles. Certainly, the Martian polar regions are different from the rest of the planet. Not only do both the north and south poles of Mars have visible caps of frozen carbon dioxide that grow and shrink with the changing seasons, both possess a smaller underlying cap of water ice that is never warm enough to melt away. The surface at the poles also looks different. A substantial quantity of ice mixed in with the rock in these locations means cliffs and crater walls tend to slump, giving them a smooth, rounded look. One of the most exciting recent developments has been the discovery of small gullies running down the sides of craters and canyons all across Mars. They look suspiciously as though they were carved by groundwater, seeping from the cliff faces and running downhill. Yet these features are so small, they must be recent. Otherwise, the steady deposit of wind-blown dust would have obscured them. Could there really be liquid water periodically bubbling to the surface on Mars? If so, the implications for life are enormous. After more than 4 decades of concentrated exploration, there's no doubt that Mars has a rich history, which certainly included liquid water and may have once included life. Furthermore, there are hints that Mars continues to be an active planet today. It is not yet a dead world, at least in the geologic sense. It is still a borderland. All of this is impetus to explore Mars further. But there are limits to what can be seen and sensed from space. To answer the question of whether Mars is a living world, we must touch, taste, and smell it. These goals can only be achieved by taking our explorations down to the very surface of Mars. Like the great voyages of discovery centuries ago, the journey to another world is fraught with danger.
Atmospheric entry on my mark.
And when it comes to landing on Mars...
5, 4, 3, 2, 1, mark.
It is always the final moments...
Phoenix now 2 minutes and 25 seconds past the entry point.
...when the peril is great.
80 meters. 50 meters.
Come on.
Constant velocity phase detected. Altitude 40 meters. 30 meters. 27 meters. 20 meters. 50 meters. Standing by for touchdown. Touchdown signal detected. Landing sequence initiated.
It is hard enough to design a machine that can land itself on Earth. But to do it on another planet, where humans have never set foot, where knowledge of changing conditions is scarce at best, to have no margin for error between a safe landing and total catastrophe, and to do it in a place that is so distant, even a simple call for help would take several minutes to reach Earth, that is a challenge indeed. But that is precisely what must be done to touch another world. So far, 6 landers have set down safely on Martian soil, and they have transformed our understanding of the planet as only first-hand experience can. Scientifically, these missions were designed to discover the geologic history of Mars, but they also carry a powerful implication about the future. It's not just the ancient past we seek when we land our probes on Mars, but a new dawn in space exploration. A red dawn. In 1976, two NASA spacecraft named Viking 1 and 2 became the first to establish a beachhead on Mars. And the view was electrifying. Geologists were immediately reminded of deserts they had visited on Earth. Once the Viking landers set to work, the similarities began to fade. While the results did not completely rule out life on Mars, they suggested that any life that managed to survive here would need to be sheltered underground or in some other impossible-to-reach location. It would be more than 20 years before another successful attempt was made to land on Mars. In 1997, NASA's Mars Pathfinder landed at the mouth of the Ars Valley, a vast channel that looks like it was carved by running water. The landing site was surrounded by broken and tumbled rock. Boulders were slanted in a downstream direction, all signs of an ancient and violent flood. The star attraction of the mission was a small rover that rolled off the lander and trundled up to nearby rocks to analyze their compositions. It was a vivid demonstration of what was needed to really begin tackling the mystery of Mars: a set of wheels. In early 2004, two rovers named Spirit and Opportunity landed safely on opposite sides of Mars. Each embarked on its own motorized trek across the red planet's surface. From the start, it was obvious that the two rovers had landed in very different settings. Spirit had been sent to Gusev Crater. Evidence from orbit suggested it was an ancient lake where standing water may have left its mark in the soil chemistry. But when Spirit opened its electronic eyes, it found a barren plain littered with volcanic rock. Meanwhile, Opportunity scored an early triumph. It was sent to Meridiani Planum, where remote sensing had spotted hematite, an iron-rich mineral that on Earth is often associated with water. Meridiani turned out to be a flat, nearly featureless plain, but miraculously, Opportunity landed in a small crater with an exposed rock outcrop. For the first time, scientists would be able to sample rock on Mars in the place where it formed. What Opportunity found after wheeling up to the outcrop exceeded everyone's wildest expectations. The rock was layered and contained ample evidence that it formed in a watery environment. It also contained hematite in the form of tiny spheres nicknamed blueberries, which grew by precipitating out of water and were later exposed as the rock weathered away. But the best was yet to come. Back on Gusev Crater, after investigating the terrain near the landing site, scientists sent Spirit rolling towards a set of distant hills, nearly 4 kilometers away. It would take 3 months to reach the hills and many more to climb them, but eventually Spirit reached the top and radioed back a sweeping panorama. In the years that followed, Spirit descended to the other side of the hills, surviving 3 Martian winters and eventually discovering home plate, the remains of a volcanic vent where hot rock once made explosive contact with water. Things were also going well at Meridiani. Once Opportunity set out across the plains, it discovered an even larger rock outcrop, whose layers read like a geologic history book. The story it told was of a place that once had been wet, but with highly acidic water, while at other times there was no water there at all. After nearly 2 years more of roving, Opportunity arrived at the edge of Victoria Crater and recorded one of the most spectacular vistas in the history of Mars exploration. High overhead, the newly arrived Mars Reconnaissance Orbiter was there to record the moment from space, spying the tiny rover perched at the crater's rim. The journey of the Mars rovers has been a scientific adventure unlike any so far in our exploration of the Red Planet. Rather than showing us Mars in an isolated spot for a brief window of time, they have shown us Mars over many years and many kilometers, including places where water once flowed. Next, scientists wanted to know about the state of water on Mars today. Compared to the Mars rovers, the Phoenix lander was a modest mission, but with an ambitious goal: to become the first spacecraft to touch water on Mars. Scientists expected to find that water locked in a frozen state just below the surface of Mars's polar regions. Here, the landscape is dominated by low mounds with trough-like boundaries. These mounds are caused by the expansion of ground ice, forcing the soil upward. After a bit of digging with its robot arm, Phoenix exposed something white just centimeters below the surface. It was ice, the first direct link to a watery past on Mars. Phoenix landed in the low-lying northern plains of Mars, an area that may once have been a Martian ocean. Although Phoenix could not confirm this, it found the soil here is alkaline, similar to what might be found in seawater on Earth. What we've learned from all these missions is that Mars was a water world, and still is today, although that water is hidden from view. As for what that means for life on Mars, that's a question for future missions. But in a sense, all of these missions are already paving the way for life on Mars, human life. The landers and rovers we build could be the leading edge of a new wave of exploration that might one day take astronauts to the Red Planet. If so, the human story on Mars has already dawned. For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. In our solar system, gravity is destiny. It is what sets one world apart from another and puts different planets on vastly different tracks. This fundamental truth begins with the sun, a giant blazing ball of hydrogen gas. The sun keeps shining because the force of gravity squeezes the matter in its core together until it is hot enough to generate nuclear reactions. Gravity also built the planets from the matter that swirled around the infant sun. In the beginning, most of that matter was in a gaseous state. But near the sun, it was too hot for gravity to hold on to the gas. So the planets that formed in the inner solar system were small and rocky. Farther away, it was a different story. In the outer reaches of the solar system, it was always cold enough for gas molecules to stick together and form ice. Billions of years ago, that ice gathered into bigger and bigger chunks until gravity took over, pulling in vast quantities of material and setting the stage for planet making on a giant scale. Here's what happens when you get enough gas together to make a planet. Jupiter is the colossus of our solar system. Beneath its swirling clouds, there's enough room to fit 1,000 Earths. Jupiter is big, too big to be a solid body. Instead, its interior is mostly liquid hydrogen, the lightest element in the universe. This hydrogen ocean is well hidden beneath Jupiter's turbulent clouds. Because Jupiter is liquid, it can spin on its axis at high speed, much faster than Earth. One day on this mammoth world lasts only 10.5 hours. This fast spin generates high-speed winds in Jupiter's atmosphere, giving the planet a striped appearance. Somehow, Jupiter's rotation also powers the Great Red Spot. A giant, swirling storm, larger than the entire Earth, that has been raging as long as astronomers have had telescopes to watch. The spot has a deep structure that penetrates many tens of kilometers, like an open window into Jupiter's atmosphere. Jupiter's visible cloud tops are made of ammonia, but scientists have not yet discovered what chemical pigment gives the Great Red Spot its distinctive color. Other storms come and go on Jupiter. This unique view, made of many separate images, shows the atmosphere of Jupiter as it would appear from somewhere above its south pole. Over time, the spots move and sometimes collide like giant ships on a stormy sea. But none have lasted as long as the Great Red Spot. The poles of Jupiter are also where we find intense aurora caused by solar particles trapped in Jupiter's powerful magnetic field. Like giant-sized versions of the northern lights on Earth, they glow brightly in ultraviolet light. Jupiter is bigger than all of the other planets combined and more dynamic, and for this reason, it is mesmerizing to watch. But there is another place in the solar system where gravity has outdone itself in creating a spectacle of stunning and otherworldly beauty. Centuries ago, astronomers were enchanted by the discovery that Saturn, the most distant planet that was known to the ancients, is encircled by what appears to be a set of narrowly divided rings. And as telescopes grew in power, so did the grace and grandeur of Saturn's rings. As these views from the Hubble Space Telescope reveal, the rings may start out at a wide angle, but eventually narrow to a thin plane, almost disappearing when the planet's equator lines up with Earth. It is because of observations like this that we know the rings of Saturn cannot be as solid as they look. A solid ring would quickly become unstable and collide with the planet. Instead, the rings must be made of trillions of icy particles, ranging in size from snowflakes to giant boulders, all guided by the gravity of Saturn and its moons. In 2004, scientists were given their best chance to learn the secrets of Saturn's rings when the Cassini spacecraft made a close pass of the rings before putting itself in orbit around the planet. As Cassini raced by, scientists trained its cameras across the ring plane, capturing one snapshot after another of the detailed patterns within the rings. These wave-like ripples are caused by the gravity of Saturn's many moons, which act on the ring particles to create shifting patterns of density, while opening up gaps which are kept free of material. In some cases, these gaps are patrolled by small moons, which shift the particles with their gravity and give the rings their sharply sculpted boundaries. Here, a newly discovered moon, only 7 kilometers across, is spotted making waves in the rings on either side of a narrow gap. Cassini has also studied the elaborate pattern of kinks in Saturn's narrow F ring. These kinks are created by the gravity of 2 moons, Pandora and Prometheus, that shepherd the ring particles and keep them on their narrow track. Among the strangest phenomena Cassini has witnessed in Saturn's rings are these fleeting dark spokes that seem to race around the rings much faster than the ring particles themselves. They are made of fine grains of dust, probably electrically charged and swept up in the motion of Saturn's magnetic field. Saturn is alive with electromagnetic energy, and like Jupiter, its poles are ringed with bright, dancing aurora. But in other respects, Saturn's polar regions look very different than Jupiter's. Here, Cassini gives us our best view yet of a strange hexagon centered on the planet's south pole. The hexagon is made of clouds and shaped by fierce winds, but the origin of its unique geometry remains a mystery. Cassini has revealed Saturn so beautifully that it is now one of the best imaged planets in our solar system, despite its great distance from Earth. Yet with each new image, Saturn continues to surprise and amaze us. This remarkable image shows us Saturn eclipsing the Sun, a view we cannot see from Earth. It is a heavenly image, even a poetic one, made even more touching by one other tiny detail. Buried in the rings, far off in the background, is a small bluish speck. Not a faint star, but a planet. It's Earth. How small we are in the solar system, but how great our reach as we send our cameras far and wide to bring us news from the lords of gravity, our solar system's largest planets. Saturn. To the ancient astronomers, it was the end of the line, the last stop before the stars. It turns out Saturn is merely the farthest planet the human eye can see. It's far, but it's not where the solar system ends. Once the telescope was invented, we discovered there was a lot more to our solar system than meets the eye. There's Uranus, Neptune, and the weird case of a planet that's not really a planet, Pluto. But even through the most powerful telescopes, these worlds remained remote and mysterious. To probe the solar system's real outer limits, you need a spacecraft. In 1977, Voyager 2 began an epic journey that would make space history. To date, it is the only spacecraft to visit planets beyond Saturn, starting with Uranus in 1986. Uranus's most obvious feature is its striking aquamarine color. This is the result of a methane atmosphere. Methane absorbs light from the red part of the spectrum, while blue light is reflected back into space. But while Uranus is unlike any planet closer to the Sun, it is not unique in the solar system. After traveling onward 3 times farther from the Sun than Saturn, Voyager 2 finally reached what is now the farthest known planet, Neptune. As with Uranus, it found a blue world, but one with an atmosphere that seemed more active, with bright white clouds made of ice crystals and dark oval storms. Compared to Jupiter, Uranus and Neptune are small, not nearly large enough to be big balls of liquid hydrogen and helium. On the other hand, they are still far larger than Earth, too large to be solid, rocky planets like our own. So Uranus and Neptune are fluid worlds, but they are mainly made of gases that freeze at low temperature, including water, methane, and ammonia. For this reason, they are called ice giants. Although you don't see any ice when you look at these planets, they must have formed from countless icy fragments that once filled the outer reaches of the solar system. Like Saturn, both Uranus and Neptune are encircled by rings, but their rings are narrow and dark. So dark, in fact, they resemble the color of charcoal and must be rich in carbon. They may be the last remnants of small moons that were disrupted by gravity and pulverized into tiny fragments. The rings are just one element in a story that suggests this quiet and dark outer region of the solar system was once witness to scenes of great violence. Uranus, for example, is nearly tilted on its side. Instead of spinning like a top, it rolls like a bowling ball, first pointing one pole and then the other almost directly at the Sun. Its rings and moons are oriented the same way, giving Uranus the appearance of a giant bullseye in space. This peculiar tilt was almost certainly the result of a giant collision long ago in the planet's history, perhaps near the time it was forming. Other signs of past collisions can be found on Uranus's bizarre icy moon, Miranda, which looks like it's been blasted apart and put together again the wrong way. Its craggy cliffs are among the highest in the solar system. Meanwhile, Neptune's largest moon, Triton, orbits Neptune backwards. How this happened is not easily explained, but it is likely Triton did not begin as a moon of Neptune. As Voyager 2 discovered, Triton is only slightly smaller than our own moon and larger than Pluto. It may have once been an independent citizen of the outer solar system that wandered too close to Neptune and was captured, perhaps after colliding with some of Neptune's other moons. Today, Triton's icy surface is crisscrossed with markings that hint at a geologically active past. The surface is made of ice, frozen water, but it's cold enough to be as hard as rock and has a strange texture resembling the skin of a cantaloupe. Much of its southern hemisphere, the only part seen by Voyager, is covered with a methane and nitrogen frost. Dark streaks on the ice are probably the sooty residue from gas geysers breaking through the icy surface. The streaks are parallel, suggesting that winds blow fast in Triton's thin atmosphere. If Triton was captured by Neptune, then it is our first opportunity to see up close an entirely new class of objects. These are small, icy, and moon-like bodies that escaped becoming part of a larger planet when the solar system formed. Now, they silently patrol the vast border region of the solar system, starting just beyond the orbit of Neptune and extending far into the deep space beyond, where the distant sun is no more than a bright star. Pluto and its moon Charon are surely members of the same family. When it was first discovered, Pluto was hailed as the 9th planet. But its tiny size and unusual orbit suggest it is not exactly a planet, but something else. In recent years, many more objects have been spotted at a similar distance, including Eris, found in 2003. Eris is even larger than Pluto. Rather than making it the 10th planet and potentially adding many more to the list, astronomers demoted Pluto instead. Now Pluto and Eris are grouped with similar objects in a newly created category, dwarf planet. The region where Pluto, Eris, and other dwarf planets live is known as the Kuiper Belt. As many as 70,000 separate objects larger than 100 kilometers may ultimately be found here. And they are clearly not all alike. For example, the Kuiper Belt object known as Sedna is redder than Mars. Its color may be due to chemical changes that occurred during billions of years of cosmic rays striking organic molecules trapped in Sedna's icy surface. Sedna's orbit stretches out far beyond the Kuiper Belt, suggesting other hidden members of the solar system may still be lurking just out of sight. Tiny and remote, the inhabitants of the Kuiper Belt appear as little more than dots, even in the world's most powerful telescopes. Yet these objects are among the most interesting to scientists, because they can tell us a story about the early days of our solar system when the giant planets were still forming out of icy building blocks like these. In 2006, to satisfy our curiosity about these most distant members of the planetary family, NASA launched New Horizons. No spacecraft has ever traveled so far to meet its primary objective, and the journey has only just begun. Now, New Horizons is well on its way to the outer limits and is scheduled to reach Pluto in 2015. When it arrives, it will be moving too fast to be captured in orbit. Instead, it will fly past both Pluto and Charon, radioing back images and data, and showing us for the first time what a dwarf planet is really like. At its closest, New Horizons will see details as small as 50 meters across on Pluto's icy surface and look for signs of past geologic activity. After Pluto, New Horizons will move on to other targets in the Kuiper Belt, including some which may not have even been discovered yet. If it succeeds, scientists hope the most distant and mysterious region of our solar system will finally seem a little more familiar. When New Horizons finally shows us Pluto, it will mark the end of an era. Pluto is no longer officially called a planet, but it represents the last type of solar system object that we have yet to see up close. Without Pluto, our story of the solar system and its history is missing an important chapter. New Horizons will write that chapter, and for the first time, give us a glimpse of the entire book. The whole solar system in all its diversity, from the blazing sun to the dark depths of the Kuiper Belt. Somewhere in that book is the story not just of rock, gas, and ice, but the story of chemical complexity and life itself.